the second square x into 10x. Okay, then fourth sum also I have taken negative sign again. That will be if I take 2 common, it will be h4 upon factorial 4, 4 into 3, that means 12 only. But 2, if I take common, that will be cancelled out. And in the bracket we will have 2 second square x, the negative sign I have taken, 2 second square x into 10 square x plus second 4x. Second square x can also be taken out. Okay, that is there. Then and so on. Negative sign and so on. This is the expansion of this function. Okay, this is log of cos of x plus h. Log of e cos of x plus h is expressed like this in powers of h. It says expand log of e cos of x plus h in powers of h by Taylor's theorem. Using Taylor's theorem, this is Taylor's theorem I am just using here. Using Taylor's theorem, I have written here. Using Taylor's theorem. Using Taylor's theorem, I have written down. This is the final answer. Log of e cos of x plus h I have written down. I have just found out what is fx, what is fx, what is f double x, f double x, and because it is to be expressed in powers of h, these powers h will be same because h is here. Okay, so that is the final answer. Question number 3 I have done. Let me take the fourth question. What the fourth question says. Now in this case, fourth question says. Okay, what the fourth question says. Now fourth question is expand sin x in powers of x minus pi by 2. Okay, this is the fourth question. This is expand sin x. Here fx is sin x. So let me take fx equal to sin x. Okay, but he says that it is to be expressed in powers of x minus pi by 2. If x is to be written as, because h and x we have to find out what is x here, what is h here, what is value of h. This is power of x, power of this means h value is x minus pi by 2. What is x then? X will be, let me write here, pi by 2 plus x minus pi by 2. We'll change with pi by 2 instead of x is x. So this is x, this is h, this is x. In place of x, I have to substitute here pi by 2. So I have to use this. Then we can express this. So what is fx here? Is sin x. If I, okay, the value I have to substitute here in place of x, what is value? Pi by 2. So that f x equal to, let me write here sin x. But if I find out what is f pi by 2, so pi by 2 I have to write in place of x. So substitute here sin pi by 2. That means the value will be sin pi by 2 means 1. It is sin pi by 2, that means 1. So first value is 1. This is first equation that we write. Okay, that is the first equation. Then what is second? If I find out the differentiation of sin x, that means cos x. What is cos pi by 2? That means f dash pi by 2 is equal to here cos pi by 2. Cos pi by 2 is 0, cos 90. This is second. Then the third, second derivative. This is minus sin x. Minus sin x. Cos x is minus sin x. Okay, and then f double dash pi by 2. If I substitute value of pi by 2 in place of x, f double dash pi by 2. That means I have to substitute pi by 2 here in this sin pi by 2. That means the same f double dash pi by 2. In place of x only, I have to replace pi by 2. So if I write here sin pi by 2, that means minus 2. This is the third equation. Now let me find third derivative. Third derivative will be minus means cos x minus cos x. Again f triple dash 0. Sorry, pi by 2 is 0 because cos pi by 2 is 0. This is 0. This is the fourth one. The fifth one then. For the fourth derivative. Fourth derivative of this will be positive sin x. Because cos x is minus sin x, minus is already there. Minus minus plus, this is plus sin x. Okay, now therefore f fourth pi by 2 will be pi by 2 sin pi by 2 is 1 positive 1. This is 1. Okay, in this way we will obtain the value of this. So now let me express by using Taylor's theorem now. So using Taylor's theorem, writing the result of it, we get or we obtain what we obtain here, sin x equal to this sin x equal to, because this extension of sin x we have to find out with the help of Taylor's theorem in powers of x minus pi by 2. So first sin pi by 2 by 1 positive, this is 1 minus second, okay, this is the third result. For the second f double dash x, this means this value, it will be minus sin, minus h, sorry, x minus, sorry, this is x minus pi by 2, x minus pi by 2 whole square on factorial 2 into this one minus 1. So minus 1 I have written here in place of f double dash pi by 2, that means 1. This is minus 5. And again triple dash is 0. Okay, this one fourth term will be positive 1. This is f fourth positive 1. This is plus x minus pi by 2 whole 4 upon factorial 4. Okay, this is positive 1. Only this value and so on, minus sign and so on. In this way we can express this value. This is 1 minus x minus pi by 2 whole square upon factorial 2. That is x minus pi by 4, pi by 2, sorry, upon factorial 4 whole is whole 4. This is whole 4. X minus pi by 2 whole 4 divided by factorial 4 and so on. This is the process of finding out x minus pi by 2. How to replace x to get x minus pi by 2, x is equal to pi by 2 plus x minus pi by 2. So in place of x we have to substitute pi by 2, and this is the value of h, because in powers of h means in place of h we have to use x minus pi by 2, and the x then what will be x, that will be pi by 2, that we have obtained here. This is the final result. Okay, so using Taylor's theorem, now solution of this question number 4 we have obtained. Now fifth question, what this question says, use Taylor's theorem to prove that this is equal to this. Very interesting question is right here. Question number 5 says that with the help of Taylor's theorem to prove that tan inverse x plus h is equal to tan inverse x plus h into sin z into sin z upon 1 minus h into sin z whole square into sin 2z upon 2 plus h into sin z whole cube upon into sin 3z upon 3 and so on. Minus plus plus minus. Okay. Now here what is given to us is z equal to, what is z here is not given here, but z here is cot of inverse x. Okay, value of cot inverse x is this. That means if I write here fx equal to tan inverse x, okay, or z equal to tan inverse 1 upon x, that is equal to cot inverse x. Okay, so this is fx equal to tan inverse x, or if I take here the series f dash x equal to, or let me write the nth series of this. What is fn? Fn x will be minus 1 whole power n. If negative or positive depend upon. If it is even number, okay, if it is odd number, then it is positive. Sorry, it is your positive, so n equal to your positive one, n equal to twice, second term. And this third one is negative, so it will be negative n. Okay, so this is n minus 1 into sine power n z into sine of n into z. where n is positive or negative. Okay, it will depend upon if n is odd or positive. From this result, if I have to find out f n x means nth derivative of this is given by this form. From this one we will obtain. Then therefore, what is f n? Sorry, f dash x. The first derivative. If I substitute n equal to 1, okay, n equal to 1 here, it will be negative. I'm sorry, this is minus 1 whole power twice n. I think this is minus 1 will be positive, n plus 1 or n here n plus 1. Because if n is positive, sorry, n is 1 right here, so it will be negative then. It is negative second term. It is positive in that case. Okay. It will be then positive. So n is minus 1 whole power this. Now let me take what is the value of this. So if it is f dash s means n equal to 1, that means why this is positive, it will be sin z. Sin n power is 1, so this is sin z only, and this is also sin z because sin 1 into z. That means sin z only. Okay, so this is the first one, first derivative. This means this one. H into this. Then f double dash x will be what? This will be here negative, this will be minus sign. His pair z into sin to z. This sin to z. But if I replace n by 2 here in this case, it will be odd number, so it will be negative. And what is the f triple dash x? That means positive. That means sin q z into sin over 3z, or this is sin angle 3z. Angle 3z. Okay. This is the next term. This is positive. The third step is positive. Okay, and so on. Then and f fourth will also be there. Can also be obtained. This will be negative. That means sin 4 power z into sin of 4z. Okay, so these values if I substitute in this equation, okay, in value of tan inverse f, this is fx, the first term, tan inverse x. Value of fx is this. Therefore, this value can be obtained by using. And now let me write here Taylor's theorem. Using Taylor's theorem, or by Taylor's theorem we obtain Taylor's theorem. We get here z equal to that we have obtained as cot inverse x. Okay, so z is cot inverse x. And fx as first is sin z into sin z. So that is the first. Therefore, using Taylor's theorem, tan inverse x plus h will be equal to first is tan inverse x with value of fx. And what fx here? Fx is tan inverse x. Fx equal to tan inverse x. This is given first. Okay, then writing other terms. Second step, because we have to write it in powers of h. Okay, and we use Taylor's theorem to prove that this h is in powers of h. So second step is h into plus h into sin z into sin z. I think the first is sin z divided into sin z upon 1. If I write no change here. Then for the second step, negative sign. This is negative h square upon factorial 2, and this factorial 2. Okay, this factorial 2 will be 2 only. That is sin of. Okay, sin 3z, that means factorial 3 upon sin 2z upon this, that will be h square upon factorial 2, that means 2 only, or it can be 2 below this, because this is whole square. This is sin z. Okay, sin z we have taken here. One sin z, which was whole square, are taken here. This is h into sin z whole square. Can be written like this. Using this is h into sin z whole square divided by this 2 can be written here with sin 2z upon 2. The same term is obtained here. Then the next term, Next term is plus h into sine z whole cube into sine 3z upon 3. Okay, and the factorial 2 equals factorial 3. So factorial 3 means there was 2 here, where 2 is obtained, that means 2 is also coming. So this 2, or this is h into sine z whole cube, okay, it was h cube upon factorial 3, this is factorial 3, there is 3 given there, okay, no change. So this is how we can obtain this series. This is the series we have obtained by using Taylor's theorem. Okay, the same thought. So that example, I mean that question was there, that how we have to use that power. So that was minus 1 whole power n, where n can be even or odd, then it's negative or positive. Okay, so this is by Taylor's theorem. This is question number 5th has been put. Let me take the next one. Question number 60 here. Okay, so question number 6. Now, question number 6. Let me take. Question number 6 says, prove that log of e x plus h equal to this. Okay, this is question number 6. It says log of e x plus h equal to log of e. This is h. It means h has been taken as this and is expressed in powers of x. Okay, plus x upon h minus x square upon twice h square plus x cube upon 3 h cube, okay, and so on. Now here, this is fx, or fx is equal to log of e h, okay, because it is clear from this is fx value, and here in place of powers we have to write here x. So it is to be expressed in powers of x. Okay, so now let me find out the derivation with respect to h. What is f dash x? That will be 1 upon h. 1 upon h here. Okay, this is there. And what is f double dash x? That means h minus 1 power minus h whole power minus 2. That means minus 1 upon h square. Okay, that means this is to be differentiated. F triple dash x equal to minus 1 into minus 2, okay, into h raised power minus 3. That means factorial 2 with minus 1 whole square divided by, this is positive, factorial, this is h raised power 3. Okay, and f fourth derivative will be minus 1 into minus 3, that means factorial 3. In the denominator it will be negative minus power 3, that means factorial 3 divided by h4, okay, so 1 more power. Therefore, using Taylor's theorem, we can write this equation as, so this is fx value, first term, therefore log of e x plus h is equal to first term, because this is fx, log of e h. This is to be okay differentiate with respect to h, with that we have done here. And first step is 1 upon h. So in powers of x, that means x into 1 upon h, that means upon h. Then is negative, second is negative minus x square upon factorial 2, that means 2 into x square. Next is positive, that means plus 2 upon 2 cancel out, so only 3, that means x cube upon h cube in the denominator, but 3 into h cube. Next will be factorial 3, okay, that will be negative, that means x4 upon the denominator 3 factorial 3 means only 4 will be there. This is h4 plus and 4. So this is the series which we have obtained. Just replacing this okay, h by x and x by h. Okay, so this is h and then differentiating that with respect to h. Okay, so this is the series we have obtained from Taylor's by using Taylor's method. This is a series of unknowns. Okay, so that is given here. Same result is obtained. Okay, so that is question number 6. Now let me take for the 7th question stage. Now question number 7 says, that extend sine inverse x plus h in powers of x as far as the term in x cube only. Okay, let me write here question number 7. It says express sine inverse x plus h, okay, in powers of x. Okay, in powers of x we have to express this in terms of up to x cube only. Okay, so in powers of x, that means it is to be differentiated again in terms of h. That is, okay, let me write here fx equal to, so here fx equal to nothing but sine inverse h, because in powers of x we have to replace this, so we have to write this, okay, in powers of x as far as the term in x. Okay, so third term. Now f dash x will be sine inverse h means 1 upon under root 1 minus h square. That means 1 minus h square whole power minus half. Then f double dash x, that means we are differentiating with respect to h. So this is to be differentiated. That means minus half, okay, 1 minus h square, this is h square whole power minus 3 by 2 into minus 2h. But this is to be differentiated again, because it's not simple x, simple h. This is minus 2h, minus 2 cancel out. This is nothing but h into, but h upon 1 minus h square whole power 3 by 2. Okay, then the third one, let me write f triple dash x. That means it can be written h into 1 minus h square whole power minus 3 by 2. Now this to be differentiated by product method. This is h as it is. Let me differentiate 1 minus h square whole power minus 3 by 2. Means minus 3 by 2 into 1 minus h square whole power minus 5 by 2 into minus 2h, because differentiation of 1 minus h square, that means minus 2h. 2 and minus 2 and 2 positive. So this is equal to, this h is h square. This is nothing but h square upon, sorry, this is by product method also. It still is not complete. Sorry, this is plus sign, because this still we have to differentiate h equal to h is differentiation 1. This is plus sign 1 minus h square whole power minus 3 by 2. So that means this 3 into h square. This is with plus sign. Okay, here h is differentiated to 1. So 1 minus h square whole power minus 3 by 2 is there. This is 3h square. If we divide by 1 minus h square whole 5 by 2. This is plus 1 upon 1 minus h square whole power 3 by 2. Okay, so if I take this 1 minus h whole power minus 5 by 2 common, if I take from this is 3h square. Okay, so this will be what this power will be, the numerator will be divided by this, but this is in the denominator, so 5 by 2 minus 3 by 2, that means power will be 1 only, for 2 upon 2, that means 1. So in the numerator we will get 1 minus h square. That is equal to, this is 2h square plus 1. So this is 1 minus h square, 1 minus h square whole power minus 5 by 2 into 1 plus 2h square. This is the next step, I mean third derivative. Okay, only up to third derivative let me write the results. This is obtained in simple one, because we have to take 1 minus h square whole power 5 by 2 or minus pi by 2 common. Okay, or 1 upon this can be taken common. This will be, the numerator we will get 1 minus h square, and the course 1 power will be obtained. Okay, so this is, if added 3h square minus h square and 2h square, so 1 plus 2h square. So this is the third derivative. Okay, now let me write the final answer as by Taylor's theorem. By Taylor's theorem, we obtain the final result, and by Taylor's theorem, we obtain this sine inverse x plus h is equal to first stability. Yeah, this is in powers of x. The first step is this sine inverse h. This is sine inverse h. This is the value of fx. Okay, plus second step is this. This is plus sine x into 1 minus, or divided by this, that we write here 1 minus x square whole power minus half. Second step, second derivative is this, h into this positive. So that will be plus x square upon factorial 2 into h into 1 minus h square whole power minus 3 by 2. Minus 3 by 2. And then plus sign, this is also plus. And that is x cubed upon factorial 3 into 1 minus h whole power minus 5 by 2 between bracket answer 2h square. This is fourth term plus and so on. Have we got this? This is sine inverse h plus x into 1 minus, or divided by 1 minus h square whole power 2 means square root of 1 minus h square, the denominator. This is x square upon factorial 2 divided into, in the multiplication of factorial 2 in the denominator, we will have 1 minus h square whole power 3 by 2 positive. Okay, and this is plus sign. This is here. Okay. Then this is plus sign. After this plus sign, this is there. This is the fourth step. So h square from factorial 2 into h into 1 minus h square whole power minus 3 by 2. This is the fourth term, x cube upon factorial 3, 1 minus h whole square, 1 minus h whole square, sorry. 1 minus h whole square whole power minus 5 by 2 into within bracket 1 minus 2h square plus and so on. Okay. Only up to third, it says up to x cube power. X cube power we have to write this expression. So this is the actual term, actual answer. Okay. So the final term is obtained. So this is the seventh question we have done. Now let me take the 8th question, 9th, 11th, 12th. So let me take what this question says. This question now is, it says expand tan inverse x in powers of x minus power by 4. Okay. So expand tan inverse, this is sorry, tan inverse x in powers of, or in powers of, it says x minus pi by 4 on right. So here I have to write here that x equal to pi by 4 plus x minus pi by 4. No change. So this is in powers of, this is h in place of h, this is in place of x. Okay. In Taylor's theorem, this is x means pi by 4. F pi by 4 we have to find out what is f pi by 4. What is h into f dash pi by 4, and h is this x minus pi by 4. So we will write this equation. Now let's find out what is this. Here fx equal to tan inverse h. This is sorry, tan inverse pi by 4. So let me write here, this is x. Tan inverse x. Now if I replace this by tan inverse pi by 4, can be written only tan inverse pi by 4. Tan inverse pi by 4 because it must be tan inverse 1 only, then it will be equal to pi by 4. Tan inverse pi by 4 only can be replaced. Okay. Now let me differentiate this. F dash x, if I differentiate, will be 1 upon 1 plus x square. Now x is to be replaced by pi by 4. This is nothing but 1 upon 1 plus pi square by 16. Okay. So it is to be differentiated either with respect to pi by 16, sorry, pi by 4, because this is pi by 4 and f dash pi by 4 we have taken here. So let me write here, this is value of f pi by 4, f dash pi by 4 equal to this 1 upon 1 plus pi by pi square upon 16. Okay, that is equal to 1 plus pi square upon 16 power minus 1. Can be like that. Okay. Then next will be, if I take this in the numerator, it will be 1 plus x square. Then we will replace by 4. So let me write here f double dash x. F double dash x will be this, will be minus 1 into 1 plus x square whole power minus 2. 1 plus x square, if I take in the numerator, it will be after differentiation into twice x. That is nothing but minus 2x upon 1 plus x square whole square. Now, I have to replace x by pi by 4. It will be minus 2 into pi by 4 divided by 1 plus pi square upon 16 whole power 2. That means pi by 2 in the numerator, or minus pi by 2 into 1 plus pi square upon 16 whole minus 2. This is value of f double dash x. No condition of that how many terms we have to write. Let me write the third step. F triple dash x. If I differentiate this is minus twice x into 1 plus x whole square minus 2 by product rule. Let me find out. This is minus twice x as it is into 1 plus x square whole power minus 2. That means minus 2 into 1 plus x square whole power minus 3 minus 1 minus 2 minus 1. That means minus 3 over into differential of 1 plus x square again with twice x. Now next step, it's negative twice x is 2 only into 1 plus x square minus 2 as it is. Differential of x is 1, twice x into, that means 2 into 1 into 1 plus x square. Yes. Let me summarize this. This is 2 to the 4 to the 6